So we would like to find the limit of this sequence. In other words, what we want is that we want as n goes to infinity. Okay, we want to see if this approaches any destination. Okay, I'm sorry. So what we have is, let's just put this in here, and you can see that it is an infinity infinity minus infinity form. So that's indeterminate. Now, what we are going to do is this, that we are going to use our old algebra technique in which we can just rationalize this portion by multiplying and dividing by what you may call the conjugate of this quantity, right? Okay, so this then times the same thing with the negative sign here between these two, the irrational and the rational quantity replaced by plus, and we are writing the same thing on the bottom. And at the same time, you may recall that a minus b times a plus b, sorry for using such a thick ink, okay, is a square minus b square. So we are going to treat this as a, and sorry, not that, I'm just feeling bad about, using so thick pen. Okay, so that is a and that is b. So what is a square? A square simply is 4n square plus 8n plus 3, and b square is how much? 2n square is 4n square. Okay, so what we will have now is that we got, so here in the numerator, I'll just write, this quantity is the square of a, as I wrote here. Okay, so we have this, and then minus simply 4n square of 2n. Okay, so that's how much? The 4n squares will cancel. Okay, so let's cancel those. This is out, and then this is out. Okay, and then we got this. That is, let me just first go ahead and erase this. So one moment. Okay, all right, so this is all gone. We don't need this anymore. Now we have to evaluate the limit of this quantity, right? And now I have to make sure that my fonts are better looking. So we want the limit of 8n plus 3 over square root of 4n square plus 8n plus 3, and here plus 2n. Now notice this, we may just go ahead and divide both the numerator and the denominator by n. Just an old algebraic technique again, in a way. So what the numerator will become? 8n over n will be 8, and then we will have 3 over n here, right? And in here, when I write this, 4n square plus 8n plus 3, and then take this n inside the radical sign, that will become n square, and then plus, of course, 2n over n will be plain and simple too. So what this quantity will become then? This will become 8 plus 3 over n, okay, divided by square root of, now I'm carrying out the division here, so that will be 4 plus 8 over n, sorry about misalignment here, plus 3 over n square, and let me erase this portion here. Okay. Back to pencil. Okay, so we have this, and then plus how much? Plus a 2. So what happens as n goes to infinity? This goes to 0, right? These two guys will go to 0. So we will have what? 8 over square root of 4 plus 2. So the final answer here is going to be how much simply? Final answer is going to be 2. And notice this, since you have your calculators available, if you got a few minutes, it's always good to check your answer. So let me just check that with you. So before I pull up the calculator, let me just erase all this. I hope I didn't make a mistake. Okay, but this doesn't look like I did. Okay, all right, but this is, I was pretty focused in here. Okay, so what we have is, we'll bring the calculator up, we'll go to y equals, and then just clearing everything from before, and instead of n, I'm writing x here, plus 3 divided by, now we have a square root of how much? 4x square, okay, plus 8x, okay, then plus 3. All right, and then we are out of the square root sign. And what did I do? I'm copying the wrong portion, am I not, right? Let me just get to this here. Sorry about that. Square root of 4x square plus 8x plus 3 minus 2x. Okay. All right, what did I do bad here? Let's see. Minus 2x. Okay. So we come here. Now we will go to our table set. Let's make sure it's okay. It may start at 100. All right. Okay. So second table set. Start at 100. Let's just go in the steps of 10 because we are, more interested in the behavior at the end. So looks like that this converges to 2 as, n goes to infinity. I'm just looking at this, and all right, looks like we have a good answer. Okay, and I'll let you run it further if you would like. Okay.